two solid spheres of same mass are made of metals of different densities. Which of them has large moment of inertia about its diameter? We know density, okay? So I'm writing over here. Density rho equals mass m by volume V. Therefore, we can write mass m equals density times volume. So we have this, okay? Now, let rho 1 and rho 2 be the density of two spheres, okay? And we have different densities, okay? So let us assume this, okay? Let us assume rho 1 greater than rho 2. So we have this. Clear? Now what we get, okay? So for first sphere, we have this, okay? M equals, from this relation, we can write rho 1 B1. And we know mass is same, okay? And for next sphere, okay, or second sphere, we have M equals rho 2 V2. Now since mass is same, therefore we have rho 1 B1 equals rho 2 V2. Therefore we can write rho 1 by rho 2 equals V2 by V1. So we can generalize this relation and write density is inversely proportional to volume. So we have this. So if density is high, then volume is small. And if density is, okay, if this is less, then the volume, okay, then the volume is large. So we find this, okay? We find this. Now, let us make a diagram, okay? Using this condition, rho 1 greater than rho 2. Therefore, V1 less than V2. So we have this. So we have two solid spheres, okay, of different volume and different density. So rho 1 is greater, okay, than rho 2. Therefore, V1 is less than V2. So we have this, and this is diameter. We are asked to find, or we are asked to, okay, compare which solid sphere have large moment of inertia about its diameter. Now we can see size, okay? Size is large, and this sphere have small size. We find this. Volume of this sphere is large in comparison to volume of this sphere. So we find diameter of this sphere, okay? Diameter of this sphere is greater in comparison to diameter of this sphere. Okay? So we find this, and we know moment of inertia I equals, this is mass times square of the distance, or we can simply write I equals mr square. So we use this relation, okay? Now what we find, okay, or what we can conclude is that for sphere having, okay, sphere having low density. So for low density, okay, size is large or its volume is large. So for sphere having low density, the moment of inertia is large. So this sphere will have large moment of inertia and this sphere will have small moment of inertia.